Sorry, I just got disconnected. This is kind of video number two connected with the video number one there. We're going to start with equation number three. We left with BAF2 combines with K3PO4, BA3PO42, and KF whatsoever what is being formed. We are not concerned with it. We just need to balance the equation since. Okay. We need to work out for this, on the left side, which is called the reactant side. We need to put some numbers to convert the odd numbers into the even one. Like for example, if you can just look at for K3, K3 is basically an odd number. So we are putting 2 beside the K3PO4. Just makes it 6. And at the same time, BAF2 is completely fine. Just you can just check it out. It's forming BA3PO42. So we can just consider these two PO4 units are actually given out in this compound. So that is already balanced, right? And at the end, if the other component of this compound is basically BA3, it demands you to provide three barium compounds. Like so, what we have on the left side as a reactant, BAF2, putting 3 besides the BAF2 makes it 3 BA providing units. So we have got balanced the BA barium, we have got balanced the two phosphate units. So the first compound is already balanced. Now look at the right one. This is Kf potassium fluoride. So first we need to figure out the number of potassium and fluorine on the left side. The fluorine is basically 3 into 2 is 6 fluoride or 6 fluorine atoms on the left side. And on the right, we just have only one. So putting 6 besides AF makes it 6 fluoride, 6 fluorine on the right, and 6 on the left. Another thing is potassium. Just look at this point. It's already unintentionally balanced. This is 2 into 3, that is 6 potassium. That is already 6 potassium on the right side. So this is why I just prefer you guys to go with, balancing ions. It helps you a lot because when you're balancing the equation, you don't need to worry about all the positive and negative ions or all the positive or negative, the components of the equation. Some of what you balance and the rest of them actually get balanced by default. So this is the science. Well, uh, this was equation number seven. And moving on to equation number eight. This is H2SO4 combines with magnesium nitrate to form MgSO4 and HNO3. Look at these points. Uh, we started with the molecule of H2SO4, providing this, SO4 units. So we firstly need to look for the SO4 units. How many SO4 units do we have in the first formula? That is only one. Since nothing is written in the subscript, like as if we had this two written along with the bracket, we could have said that we have got two sulfates in one formula. So this is not the rule right now. It is just only one SO4 and H2SO4. Just look on the right side, MgSO4. So MgSO4 also contains one unit of SO4, which is basically given by the H to the 4 from the left side. So SO4 is already balanced. You don't need to worry about this oxygen, this sulfur connected together in the form of SO4. The next thing is NO3. Balancing the NO3. NO3 units are given with the subscript of 2. That means we have got two nitrate, two NO3 units on the left side. Just look on the right. The final formula contains an HNO3. That thing is given with the subscript as along with the brackets on the NO3. That means we just have only one nitrate on the right and two on the left. So just to balance it, we just put two besides it. Or I just want to write it. Okay, then two nitrates. Okay, then the next thing is two hydrogen, which gets balanced automatically. If you can just surprising, magic. Equation number 9 again. Al combines with H2SO4, again an equation with SO4 units. Just look at this SO4 unit first, one on the left, and just look at this, three on the right. So we got a direct impression that we get some 3 units of H2SO4 to serve them to give the 3 units of sulfate at the end. Getting my point? Let me just write 3 besides H2SO4. That makes it providing 3 SO4 units, right? And those 3 SO4 units are get balanced on the right. What about this aluminum? Aluminum is got number 2, so we can put any number that along with aluminum because it's not going to bother with the other elements. Okay, 2 aluminum on the left, 2 on the right, 3 sulfates on the left, 3 on the right. What about this hydrogen? Hydrogen is basically given 2 on the right and 6 on the left. So makes it 6, we just put 3. So that makes it 6 hydrogen on the left side, on the right side as well. Now, question number 3 is tungsten oxide. You might have not, you know, gone through this kind of formula because we are not familiar with tungsten. Tungsten is T, and I don't know the letters are working this way. WO3 is tungsten oxide, which is called tungsten 3 oxide at the same time. Combines with hydrogen to form tungsten and H2O. Now, first we need to look for any kind of odd numbers on the left side. So I have actually figured it out. If I just put 2 besides tungsten trioxide or tungsten 3 oxide, that makes it 6 oxygen rather than 3 oxygen atoms. So you just need to put some numbers before tungsten to get it balanced on the right as well. So we just put in 2 on the right. So that makes it completely balanced for tungsten. Now look at this point. We need to balance the oxygen. Oxygens are 6 on the left, since this 2 multiplied with 3 to give 6 oxygen on the left. So this 6 is balanced by putting a 6 besides H2 on the right. 6 on the right and 6 on the left. And at the same time, hydrogen gets disturbed completely because hydrogen is 12 on the right and just 2 on the left. So if we just make it, we just want to make it 12, putting 6 beside us 2. Make sense? So we have got balanced the 10 initial equations given in the worksheet. I have actually placed the link for the worksheet. You can actually download it and possibly agree with it. Plus, if you find this video helpful, do share with the others. Thanks.